Good morning, everybody. So I think we started the next concept in carbons compounds. That is what is combustion actually. So now we all know, as I already taught you in yesterday's class. So we are having two different kind of hydrocarbons. So that is what we used to say. One is saturated hydrocarbons and another one is unsaturated hydrocarbons. So if you observe here, as I said, if you take the saturated hydrocarbons, if you notice it, the percentage of hydrogen is more or less, everybody? Yes, please. The percentage of hydrogen is very high. So that is why they will burn with a what flame? Everybody? They will burn with a smokeless blue flame. So all of you remember, saturated hydrocarbons, they are having high percentage of hydrogen. That is why they will burn with a smokeless blue flame. So basically the fuels which have high percentage of hydrogen are the burning smokeless blue flame is considered as the better fuels. The fuels what we have in our surroundings, majority of the fuels are hydrocarbons or derivatives of hydrocarbons. So in that, which fuels is having greater percentage of hydrogen, they are considered as the best fuels or top fuels. So if you take, for example, the smallest possible hydrocarbon, which is the smallest possible hydrocarbon, everybody? Which is the smallest possible hydrocarbon? Yes, please. Methane. Understand? So methane. So if methane will react with oxygen, so we all know that they will give you carbon dioxide plus water vapor plus they will produce us what? All of you? Heat. So that is why we used to say they are the exothermic reactions. So they will produce us large amount of heat energy. So whenever they burns in oxygen, sufficient amount of oxygen, that is what complete combustion, they will produce us a huge amount of heat along with the carbon dioxide gas and as well as water vapor. Or else if you take the derivatives of these hydrocarbons, like for example, if you take methanol as we studied, so what is the functional group present in the methanol? Everybody? What is the functional group present in the methanol? All of you. Functional group present in the methanol, OL. OL is present. So what is it call it as? All of you. Alcohol. So methanol is also, what is the common name of methanol? Anybody? What is the common name of methanol? All of you.
Methyl alcohol.
Alcohol. Mr. Ashik, are you there? I want response immediately. Mr. Ashik and Nimish. Pugal also. So methyl alcohol. So if it is react with oxygen, complete combustion. So it is to produce carbon dioxide plus water plus heat. So yesterday I taught you even this balanced equation also. So balanced equation also kindly try to learn. So 2CH3OH react with a 3O2 will gives you 2CO2 plus 4H2O. So that is what burning of methanol or methyl alcohol we used to say. So now, if it is incomplete combustion, Ashik and Pugal, I called you. So if it is insufficient supply of oxygen, so what will happen? So during incomplete combustion, so what will happen, everybody? During incomplete combustion or the combustion lack of oxygen. What do you mean by incomplete combustion? Lack of oxygen means there is no sufficient supply of oxygen. So instead of carbon dioxide, it will produce most dangerous gas. What is that, everybody? All of you?
Carbon monoxide.
Incomplete combustion always leads to produces a poisonous gas which is called it as a carbon monoxide. So either methane, or you can take most probably this is the most common reaction in old automobiles. If you take like our bikes, cars and all, so which are becoming extremely older, like 30 years, 20 years, 15 years of manufacturing day. So this all will leads to production of carbon monoxide. So that is why if you take the complete oxidation does not. Sir, what is this incomplete combustion? Complete oxidation does not take place. Oxidation reaction, complete oxidation does not take place. So that is what we used to call it as a incomplete combustion. Mr. Ashik, I called you 2 times. Are you there? Now, not only this one, not only this hydrocarbons. If you take pure carbon also, like a coal. So coal is the purest form of carbon. Purest form of carbon. So now carbon, we all know. So what is the symbol of carbon, everybody? Carbon symbol
C.
T. So if you take the carbon, that is what coal is one of the example of carbon. If it is also incomplete combustion, means no sufficient supply of oxygen, then it will also leads to produce what, everybody? Carbon monoxide. So most dangerous gas. So balancing 2C plus O2 gives you 2CO, carbon monoxide. So this is what is about saturated hydrocarbons and whatever it is derivatives. So always remember, saturated hydrocarbons, percentage of hydrogen is high and they will burning smokeless blue flame. That is why they are called it as a better fuels. Do you understand what I'm saying? My absentees, everybody call fastly one by one. Are you understand, all of you? Mr. Ashik, Danishka, ready? So now, if you have taken all of you unsaturated hydrocarbons, what is the examples of unsaturated hydrocarbons, all of you? Unsaturated hydrocarbons starts from where? Unsaturated hydrocarbons starts from where? That is what is my question. They will start from n is equals to 1 or n is equals to 2. Everybody. N is equals to 2.
Any
Minimum number of carbons will be 2. That is what? C double bond C. If I have taken, this is what unsaturated hydrocarbon. We used to call it as a alkenes. And C triple bond C. See why? What is the purpose? Every time I will draw. If there is a someone who don't know, who forgets. That is the person he has to learn it. That is the reason every time we will write it. So unsaturated hydrocarbons means alkenes or alkynes. So now, if I burn, if you see these two, so remember in this, the higher percentage of carbon will be and lower percentage of, note it everybody, higher percentage of carbon and lower percentage of hydrogen. Do you understand, everybody? So hydrogen, why sir? Hydrogen is the best fuel. Basically, we want to speak, hydrogen is the green fuel. So green fuel, eco-friendly, pollution-free. That is the purpose we need basically hydrogen. Okay. So now, if you take here, that is the reason higher percentage of carbon is there, lower percentage of hydrogen. So that is why they are considered as not good fuel, not considered as good fuels. So now, like kerosene and all. So they also produce unburnt carbon in the form of soot actually. So that is what like a smoke will say, a black powder like substance they'll produce. And it will be like, you can see, how many of you are, you might be visited villages and all. So the food which is prepared, a bowl which is prepared on, you can notice it by burning the firewood. So if you are having a stove, like a firewood stove, so if you are burning the wood and if you are cooking the food, you can see the bottom surface, everything will be turned up into the blackish. Have you noticed it, everybody? Yes, please. The bottom surface of the bowl will turn up into blackish. Yes or no, all of you? Yes, please. So while cooking, you can notice it. That is what we used to call it as a unburnt carbon. So it is actually soot actually. So only unsaturated hydrocarbons only they will produce it. Suppose if you are cooking in the stove, you can see the bottom of the utensils will never turn up into black. Am I right, guys? I'm asking you people, you have to tell me. Am I right or wrong? So why? What is the reason? The gas is a what? Saturated or unsaturated hydrocarbon? Gas. All of you? Gas is a what? In our home, the gas what is present is a saturated or unsaturated? It contains butane. C4H10 is a saturated or unsaturated? All of you. It is saturated. So it will burn with a blue flame. No soot particles will produce. No soot will produce. So that is why the bottom surface will never be turned up into black. But if you are cooking by burning the firewood, you can notice it automatically. Even just 2-3 times if you cook also, the surface of the bowl will turn up into black. That is what? Because they are not considered as a good fuels, and this unburnt carbon, note it, unburnt carbon in the form of soot which gets deposited at the bottom of utensil and around it while cooking, around it while cooking. Or else you can see, for example, many of us, we are traveling in a road. During that, we can feel that some vehicles are exhausting too much of smoke. Do you all experience it? Even we used to scold sometimes, what is this nonsense? This much smoke is coming, like that, we will feel it also. Am I right, everybody, guys? Please respond. So that is what we used to call it as a unburnt carbon. If the vehicle is not serviced properly, or some of the drivers, if the owner will give the money for the petrol, they will mix the petrol with the kerosene. So kerosene is actually a unsaturated hydrocarbon having more number of carbons, not unsaturated hydrocarbon. The number of carbons are keep on increasing. So for example, all of you observe, even the saturated, tell me what one three compounds of saturated, make it fast. Saturated compounds, make it fast. CH-4. Next one. C2. Tell me fastly. C2H6. Next one. C3H8. Next one. C4H10. Now, whom do you think it is a better fuel? Methane or ethane or propane or butane? Which is more better fuel? Anybody? What is your opinion? You tell me. Which is more better fuel? Methane. Methane is
Butane.
more better fuel than ethane. Ethane is more better than butane. Butane is more better than propane. Propane, like that. Do you understand, all of you? So methane is the best fuel. Why? The percentage of carbon is least percentage. That is important for us. More than a percentage of hydrogen, the number of carbons is less. So it will be the best fuel. That is the point you all need to remember. Are you understand what I'm saying, everybody? Clear, all of you? So having a less number of carbons, that is the best fuel. That is what you have to remember. Gayatri, join with the number. Make it quick, everyone. All of you. So that is what. I hope you all understanding, everybody, guys. Clear? So now, for example, I will give you unsaturated hydrocarbons. For example, the C2H4. Next one, C3H6. C3H6. Next one, C4H8. Now, in this, which is the best fuel? I ask you to compare in these three, which is the best fuel? Which is the best fuel? Ethene. Do you understand, everybody? Compared to ethane, next one, propane is little more smoke. Next one, butane is more little smoke, because the number of carbons is keep on, the percentage of carbon is keep on increasing. I hope you all understand, everybody. Are you clear? Yes, please. So, this unsaturated hydrocarbons along with the, of course, they are having a high percentage of carbon, so that what will happen? They will burn with the smoke. They will burn with the smoke. Note it, everybody. They will burn with the smoke, and they have lower calorific value. So this one, 8th class, you might be studied calorific value. So I want to speak about it. That's what I'm speaking. So calorific value, anybody is remembered? Any one of you? What do you mean by calorific value? So note it. If you don't know, write it. Calorific value is defined as 8th class, 7th class, you will definitely study. Have you studied about the fuels? Combustion and flame in 8th class. There is a chapter in combustion and flame. Anybody remember? Class 8th, combustion and flame. You might be remember. Hydrogen is the highest calorific value, 1,50,000. 1,50,000 kilojoule per kg. Do you remember, all of you? That is the calorific value. So defined as, please note it. Don't think that it may not ask in exam. 100% they will ask you. So calorific value means defined as maximum heat produced, maximum heat energy produced while burning 1 kg of fuel. Any fuel it is. It is a wood, cow dung, understanding, or the petrol or diesel or hydrogen or whatever it is. Any fuel, if you burn 1 kg, the maximum heat energy produced per burning of 1 kg of fuel. That is what we used to call it as a calorific value. So what is the unit of calorific value? Sir, calorific value unit is kilojoule, unit of energy. Note it. Electricity, physics we studied. Do you remember, everybody? Joules, kilojoules. That is what. So kilojoules per kilogram. That is the unit of calorific value. Note it. 100% question comes means they will ask you based upon calorific value also. So be very careful. Now you tell me, who is having high calorific value? What is your expectation? Methane, ethane, propane. Who is having highest calorific value? Anybody?
Methane.
Methane. Do you understand it? So that is what. Note it. Calorific value is greater. Best fuel. The best fuels is always having highest calorific value. That is what you have to remember. All of you understand? Yes, please respond, guys. So now you can see, everybody. Now let me take the two unsaturated hydrocarbon. What is the first unsaturated hydrocarbon? Alkenes. Alkenes, what is the first unsaturated hydrocarbon? Make it quick, everybody. C2,
Ethane.
C2H, C2H4. C2H4 means what will happen? In the form of bond, you write it. CH2 double bond CH2. Am I right or wrong? Everybody, hurry, you take it option is hurry. I want to see today. So C2 CH2, CH2. Am I right or wrong? Please respond, guys. Everybody. Ethane actually. So ethane reacting with oxygen. So note it, everybody. It will produce carbon dioxide plus water vapor plus it will produce heat. But it will also releases what? Unburnt carbon in the form of what, everyone? In the form of what? Please respond. Unburnt carbon in the form of what? Soot particles. That is what you have to remember. And I'm saying again, you are not responding, then what I should say. So ethane, CH, C2H2. So ethane will react with oxygen. Note it. Oxygen, they will produce as carbon dioxide plus water plus heat energy. So remember, unsaturated hydrocarbons are burnt in pure oxygen. They will completely burn with that, if understanding everybody, and they will produce us basically unsaturated hydrocarbons. They will produce soot, unburnt carbon in the form of soot. That is what you have to remember. So they are smoke fuels, the fuels which will burn with the smoke, and they also burn with the, clear everyone, they will burn with the yellow flame. So that is also we'll discuss it. So that is a secondary. But you remember there is a case. So all people will think that unsaturated hydrocarbons always they will burn with the yellow flame. But you remember, if it is pure oxygen, it will react with that. Book also I will underline. Everybody underline it. Unsaturated hydrocarbons also they will burn with the blue flame without smoke and produces blue flame. When, you know guys, that is what you have to remember. If you can see everybody, saturated hydrocarbons, that's fine. Now you can see unsaturated, even unsaturated hydrocarbons giving a sooty flame. Okay, sorry, saturated hydrocarbons giving a sooty flame when there is a incomplete combustion. So note that point. If there is no sufficient, this is very important, Amma. So saturated hydrocarbons also they will give the sooty flame. When guys? When there is, understanding, incomplete combustion. So what will happen? Saturated hydrocarbons also they'll give the sooty flame. So that is what, like a gas or kerosene stove used at home has inlets for the air. So a sufficient oxygen rich mixture is burned to give a clean blue flame. So that is why if you see that gas stove, then you can see the utensils what we are using in the gas stove, the bottom of the cooking utensils getting blackened, means in the sense of the air holes. Go and see your gas stove. Middle, there will be a small air holes one. Have you noticed that? From that only gas will come. Am I right, everybody? Please respond, guys. Have you checked it, all of you? Everyone? Have you seen the gas stove or not? Now, you can see it. If this glass, that holes are blocked, then you can see your blue flame will turn up into, yellow. Means in the sense of, by the time the air supply is not sufficient, if there is no proper supply of oxygen, then your gas stove also will produce us the sooty flame and yellow flame. So that is why it means the air holes are blocked and the fuel is getting wasted. Means it is undergoing the incomplete combustion. So that is, you have to remember. Are you understand, everybody? So that is why this is also very important. The fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. This is also major important, along with the hydrocarbons. Basically, coal is a pure form of carbon. Petroleum is a mixture of, note it all of you, mixture of hundreds of hydrocarbons. So now, along with them, there is another substances also, nitrogen and sulfur. So their combustion results in formation of oxides of sulfur and nitrogen. Oxides of sulfur and nitrogen, which are major pollutants in the environment. That is what you can see. Sulfur dioxide, nitrogen monoxide, sulfur trioxide. These all are producers and they are the pollutants of environment. So very important point. So if you remember, saturated hydrocarbons also they will produce as sooty flame. When? Anybody? When there is no sufficient supply of oxygen. Do you all understand what I'm saying? Everybody? Please respond, guys. All of you? Yes, please. More clear, Ma?
Yes, sir.
Yeah. Now, sir, is that unsaturated hydrocarbons always produces black smoke or sooty smoke, black or sooty smoke, unsaturated hydrocarbons always will give a yellow flame with a lot of black smoke. Is it true? No. So note that point. If the unsaturated, write it everybody, if the unsaturated hydrocarbons are burnt in, burnt in pure oxygen, then they will burn completely, without smoke, and produces what flame? Without smoke means what is the color of the flame? Everybody, you have to tell. What is the color of the flame? Without smoke means immediately mind should say it is a what flame? All of you.
Blue
Flame. Remember that. So that is the reason, if the holes of the gas stove which are present at the base are blocked, then you remember it will leads to insufficient supply of oxygen. So automatically it will blackening the bottom of the cooking utensils. Even you can notice it, some of the holes are blocked, immediately yellow flame will come. So that is what you have to remember. Okay, everybody, clear? Understand, Amma? All of you? Please respond. Now, so to prove that there is activity also. So this activity needs to the teacher assistance. So take some carbon compounds. You can notice it. So to show that yellow and sooty flame, and as well as blue and smokeless flame. So compounds like naphthalene, camphor, alcohol, one by one as on a spatula, and burn them. You can see what will happen. All of you will take it, everybody. So to show the incomplete combustion, so we need basically like a flame, while the complete combustion gives a blue flame. So we will take it, it is actually, when do you get a yellow flame, a sooty flame? When do you get a blue flame? This is the activity and this is the activity to show the different composition. So both we can do it, nothing wrong with it. So let us finish this first, because we want to get a different types of flames, presence of a smoke. So if you notice it, so if you take here, what is happening? When do you get a yellow sooty flame, everybody? When do you get a sooty yellow flame? When the holes of the, when you will get a sooty yellow flame, guys? The holes, the supplying oxygen holes. If you observe, the holes are blocked and fuels getting wasted. By the time, what will happen? If there is no sufficient supply of oxygen, so by the time, instead of blue flame, you will get what flame? Everybody, all of you. Yes, please respond. Instead of blue flame, what will happen? If the holes is blocked, we'll get what? All of you.
sooty
Yellow
flame.
flame. Understanding? Yeah, sooty and yellow flame. So that is what it will be happening. So for example, so if you notice it, so different flames you can see, just a minute. So you all can see in our surroundings, we can notice the different flames while you are burning it. So this is what, for example, if you notice it, so I'm getting the yellow, here you see that, fully completely yellow, light, somewhat near here blue flame, here somewhat of almost blue flame, here completely blue flame. So now what makes here, if you see here, so air holes completely closed, means very less sufficient supply of oxygen. Everything is our gas stove only, same gas stove. Now here, air holes are slightly open, means only few air holes are working, remaining everything blocked. Now air holes are open. Now here, hole almost fully open. So completely air holes are free, like you can say new burner. Then the flame will be like this, blue flame. So this is what smokeless blue flame. Understanding? And this is a yellow flame with a sooty flame, yellow sooty flame, or we can say black flame. Do you understand what I'm saying, everybody? All of you clear? So now, basically unsaturated hydrocarbons, they will produce a yellow flame only. But if there is a sufficient supply of oxygen, they also will undergo completely without smoke and they'll produce this blue flame. That is you have to remember. Understand, Mr. Omar, Sanjay Kanan, all of you clear, everybody? So this is what you have to remember. So if the incomplete combustion of fuels takes place in what? Insufficient supply of oxygen and fuels burn with a yellow sooty flame, or we can say black flame, yellow sooty or black flame. And if there is a sufficient supply of oxygen, then they will burn with a completely sufficient supply of oxygen. They will burn completely and they will produce us what flame? Everybody? What is the flame they will produce us? All of you. Yes, please. They will produce us blue flame, smokeless flame. So that is you have to remember. Now, either your gas stove is working properly or not. Sir, how to identify? If your utensils are getting the black deposit, black substance at the bottom, means your gas stove burner is not working properly. So if you are not getting any black deposit at the bottom of your utensils, then definitely your burner is functioning well and there is no smoke is emitting by the burner. Means incomplete combustion is not taking place. That is you have to remember. I hope you all understand. Anybody having any doubt, please let me know. Are you clear, everybody? All of you understand? Yes, please. Respond, Ra. All of you? Okay. So now, if you take, sir, why do substances burn with or without flame? So this is also thing. So we can notice in our surroundings, some substances we notice they'll burn with the flame and some substances they'll burn without flame. And if they are burning with the flame, the flames are two types. What is the two types of flames we have? All of you, just now we studied. One is blue flame and another one is a what flame? All of you. Yes,
Yellow
please. Yellow flame. So now, this one, there is no kind of important content for us to learn. So, but there is a matter they have given in the boxes. So, that is the reason. Let us have a glance and we'll finish this. So, why do substances burn with or without a flame? So, everything hydrocarbon, but some will burn with a flame and some will not burn with a flame. So first of all, understand what do you mean by flame. Okay, so write it. So flame is a region. It is the region where combustion of gaseous substance takes place. Do you understand, Mr. Pugal, Rohit? Understand, everybody? So combustion of gaseous substance takes place. That is what we used to call it as a flame. So now, if you observe here, so different types of flames we can see. As we know, if the candle is burning, we can see that, and cooking gas is burning, we can see, and you can see they're having some color. Cooking gas, we can notice it blue color. Candle always burn with the what color? Candle will burn with what color? Nobody. Yes, please. Candle is burning with what color, all of you? Yellow color. LPG cylinder, liquefied petroleum gas in the gas stove, burns with a flame. What is the flame actually? It is a blue flame. But you will observe the coal. If you go to the person, ironing person, the man who will iron your cloth and all, he will be having a coal. Have you seen that? That coal is